So over here, you have positive static analysis again. So we have 3000 plus P, right? So we have 3000 plus P minus by 2000 x minus 1.5, right? And then we have minus V as a function of X, the whole thing is equal to 0. So V as a function of X, right, is equal to 3000 plus P minus 2000 X minus 1.5, okay? So if I have to write this out, this is 3000 plus P minus by 2000 X minus by 1.5 or plus, okay? So 2000 times 1.5 is equal to 3000. So this equation over here is minus 2000 X plus P plus by 6000, right? So at point C, where X is equal to 1.3, oh, sorry, it's equal to 3, not 1.3, okay, 3.0. What we have is V at point B is equal to minus 2000 multiplied by 3 plus P plus 6000. At the end, we're left with P at point B, which is true. If you look at our structure, it ends up at P down here, okay? So from here, we can sketch out the shear force diagram, okay? So we're going to make a sketch, okay? So shear force diagram. So this is going to be our X. And this is going to be our Y. So this is 0, 1.5, and 3, okay? And this is P, and this is equal to 3000 plus P, okay? So this is your V. So it's going to stick at 3000 plus V, okay, until at 1.5, right? So if you look at our function over here, right, where X is equal to 1.5, we are at 3000 plus. Then after that, you have negative slope coming down, okay, and then it will come down to at 3 meters. Okay, this is a straight line, not a curved region. I'm going to draw a straight line, okay, so there's no misunderstanding, right? Then after that, it's going to go down 0. So this is your shear force diagram. So this equation over here, what we have just drawn, this is our minus 2 or V as a function of X minus 2000 X plus P plus by 3000 over here, okay? So we realize that at this point over here, this level over here, this is our V max, right? So our V max is equal to 3000 plus P. So this is the value that we should be. So that is the purpose of the shear force diagram. But sometimes you can go by observation, by looking at the equations, okay? By looking at these equations, okay? Like VB, Vx down here, VB, and by looking at these functions over here, you know, right? You can visualize the diagram and you immediately say, okay, Vmax is equal to 3000 plus P. I'm fine with that. But because I'm teaching now, I want you to get used to forming your shear force equation anyway. Okay, so we are going to select Vmax is equal to 3000 plus P. Okay, because this will dictate your value of P, okay, from two modes of failure. Okay, so let's go into mode 1. Okay, so due to the fastener, so we know that Q is equal to F. So we know that F is equal to 2 times 10 to the power 3 resistance force divided by the spacing of 0.1 meter. And then you have to multiply by 2. This is because of left and right nail. Nails, right? So this will be equal to 2 power 3 times 2 divided by 0.1 is equal to 40,000. Right, Newton per meter. And this whole term over here is equal to Vy over Izz, right? And multiply by Qz. Right. So we know that Vy, so this will be equal to 40,000, is equal to 3000 plus P, right? Qz over Izz. So the next thing we have to do is to find the centroid and Izz. Okay, so that's where I had this diagram sitting around. Right. Okay. So we are going to find. So this is our z direction, right? X and Y. So this direction will be the width, and this direction over here will be our depth. Okay. So I'm going to call this our flange, and I'm going to call this our web. Okay, web. Right. So I'm going to do our section again. So we have flange, web number 1. There are 2 webs. Number 2. Okay. Then from here, we're going to find out the width and the depth. So the width is 200. Depth is, hold on, let me write bigger. The width is 200. The depth is 40. And then for the other, the width is 20. The depth is 200. Web number 2 is the same. Okay. So 20, 40, 200. Okay. So this will be equal to 200 times 40, 8,000. This is equal to 4,000. 4,000. Okay. So this is 16,000. Okay. Then the next one, we're going to look at the individual section centroid. Okay. So I'm going to take data from the top. Okay. So this is our small y bar. So this is 40 divided by 2, 20. This is equal to 200 divided by 2, 100. This is the same. Okay. Then we combine all of them together, multiply, sorry, not combine. So you have our omega d and y bar. 20 times 8,000, 20 times 8,000 is equal to 160 times 10 to the power 3. 4,000 times 100 is equal to 400 times 10 to the power 3, and 400 times 10 to the power 3. So 160 plus 400 is equal to 960 times 10 to the power 3. Okay, so we can immediately find our y bar. So it's 960 times 10 to the power 3 divided by 16,000. Okay, so 960 power 3 divided by 16,123 is equal to 60 millimeters. Okay, is equal to 60 or 0.0 or 60 millimeters from the top, or because the entire thickness is 200 minus 60 is equal to 140 millimeters from the bottom. Okay, so we will take things from the top. So now you can immediately find your I. Okay, so IZZ for your flange. So it's equal to 200 with depth plus by 8,000 multiplied by 60 minus by 20 squared. Okay, so 200 times 40 power 3 divided by 12 plus by 8,000 times by 60 minus 20 close bracket squared. So it's equal to 13.8667 or 13.867 times 10 to the power 6 millimeters 4. Or I'm going to check again. So whenever you do calculation, you have to check. Okay, 8,000 times by 80 minus 60 minus 20 close bracket squared, 13.866 times 10. All right, or 13.867 times 10 to the power minus 6 meter 4. Okay, then you have IZZ of the web. So this will be equal to 20 multiplied 200 cube over 12 plus by 4,000, 60 minus by 100 squared. Okay, so 20 times 2,000 power 3, 200 power 3 divided by 12 plus by 4,000 times by 60 minus 100 close bracket squared. You have 19.733 times 10 to the power 6. Okay, so let me try again. 20 times 200 power 3 divided by 12 plus by 4,000 times by 60 minus 100 close bracket squared. 19.733. Okay, so now we can calculate our IZZ is equal to 13.867 times 10 to the power 6 plus by twice of 19.733, because you have the left and the right flange, web, sorry. So 13.867 power 6 plus by 2 times 19.733 power of 6. So it's equal to 53.333 times 10 to the power 6 millimeters 4, or 53.333 times 10 to the power minus 6 meter 4. Okay, so this value we have. So we also know where our centroid is. Okay, so let's find. So we are going to look at the failure of the fastener, right? So remember, I told you guys to construct the shear flow, right? So we're going to construct the shear flow, right? So rule number 5, the web controls the direction of the shear flow. Okay, so over here, this is where our Vy is. right? So this is our Q, right? So the web controls the direction. So